Hey, welcome back, physics fans. We're on the last lesson here of chapter 3.2, linear momentum, one dimension. And yeah, here we go. It was about recoil, what we covered beforehand, but we left it off with this. The happy and sad balls that are bouncing off the floor. One bounces high, the other one goes splat and sticks. Now, when we throw these balls at a wall or at an object and it hits up high, and we're trying to find, and if we're throwing them with equal speeds, which one is more likely to knock the block over. All this red stuff was just a review of what we learned up to that point, not necessarily helpful with this. Which one is it? Well, yeah, it is helpful. Okay, we want to know which one hits with the larger force. Which one hits with the larger force? Times time is mass times the change in velocity. Now, the larger force will push it over. They are traveling at the same speed, so when they hit with the same amount of time. The impact time is the same. Their masses are the same. Excuse me. So we want to know which one will have the larger change in velocity. And most times people will say, oh, it's the same, but it's not. The splat one, the VI is the same as the VI here. The VF here is 0. It sticks and tries to knock it over. The happy one, bounces off. So there's a velocity afterwards. So the change in velocity here is higher. Because not only does it stop, but it also adds an extra V the other way, the VF the other way. So the change in velocity is higher here. So the object that bounces has a larger change in velocity. Now, we are assuming that it takes the same amount of time of impact. And why is that so difficult to understand? Well, because we kind of think when something sticks to it, it does more force. When something goes splat and it sticks to it, it was there and it knows and it sticks to it. But these, if we're trying to compare it with something that we throw that bounces, the things that bounce are usually lighter than the things that go splat. So we have to think of them at the same mass. And if they are the same mass, they bounce with the same amount of time in contact with the wall with the same amount of time till they stop or till they bounce off, then the change in velocity is larger, so the force will be larger. Okay, so what's coming up right now are some 3 questions that I would like to go over with you. These are just random questions that I've pulled from provincial exams and just want to get you up to the level of provincial exams in one dimension momentum. They're not hard, but what you can do now that you're on YouTube, if you're not ready for it, well, save this video. And if you are ready for it, well, then you got to use the pause button. Use the pause button and try it out. I'd like you to get ahead of it instead of just watch it. This is not famous players. YouTube turns out to be famous players, but I don't want it to be that way. I want you to be trying it out. Okay? You don't have to copy down the question. I have it here on YouTube. You can always come back to it. Okay? Just pause the question and try out number 7. Yeah, I'll start doing it in 5 seconds. 4, 3, 2, 1. Blast off! Yes, we have ignition. Okay, a 0.15 kilogram ball traveling at 25 meters per second strikes a wall and bounces back in the opposite direction. Oh, you know why I chose this question. The ball is in contact with the wall for 0.03 seconds. What's the average force? So we have that impulse is the change in momentum. And impulse is force times time, and the change in momentum is m, if you want, change in velocity, which is going to be m vf minus vi. Okay, and we want to know the average force. So this is what we're trying to calculate, so I'll put that in black. Okay, so the force times 0.03 seconds is equal to the mass, 0.15 times the change in velocity. So VF 15, opposite direction, and VI is 25, change in velocity. And the change in velocity here is not 10, but 40. Okay, now we just pull up our calculators and see how it works. Hello, Mr. Calculator. So we go 0.15 times 40 divided by 0.03. And we get 200. The force here is 200. And that'll be in newtons. And the answer is D. Hope that's what you got. Thank you for trying it. Here we go. The next question. Remember, pause it. You have 5 seconds. 5, 4, 3, 2, 1. We have liftoff. Yes. Okay. Block A of mass 15 kilograms is traveling at 7.5 meters per second due east when it collides with the block B of mass 9 kilograms traveling at 11 meters per second due west. Block B bounces back at 6. What is the speed and in what direction will block A move? So this is a collision one. This is M1V1 plus M2V2 is equal to M1V1 prime plus M2V2 prime. Why do I come up with this formula? It's because the momentum before is equal to the momentum after. You need to write this down. You do it without thinking. Boom, it's a collision. Boom, you write that down. So let's start filling in some of the numbers. 15 moving at positive 7.5, emphasizing that this is going to be positive. So this one's going to be negative, plus the mass of 9 and negative 11 is going to equal the mass of 15 times V1 prime, we don't know that one, is equal to, no, not equal to, whoops, boom, 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 plus M2, 9, moving at positive 6, because this direction is positive. Okay, so pull up our calculator. 15 times 7.5, 112.5. And that's going to be a negative 99. So subtract 99. The total momentum, whoa, so that subtracted 9. Now I have to subtract 90 as well. So the total momentum of the system is 13 kilograms, 13.5. 13.5 kilograms meters per second. Okay, the bonus question, write your answer down in the comment. That's my bird clock chirping in the background. You have to determine what time it says. So you have to look up bird clocks, sounds. Each hour is a different bird. You have to identify that bird and put it on the clock and put it in a comment down below. 5,000 bonus marks. V1 prime plus 54. Okay, so bring the 54 over to the other side. So subtract 54, and we get negative 40.5 is equal to 15 v1 prime. Divide this by 15, and we get v1 prime is equal to negative 2.7 meters per second. And the negative means what? The negative was west. So v1 prime is equal to 2.7 meters per second west. B. There we go. And I think we'll stop there. Thank you very much for paying attention. Go through some of the ultimate review questions if you want, or get ready. Let's get ready for some of the mastery quizzes up on the Moodle. And as we go into chapter 3.3, which is momentum, but in 2 dimensions. Anyhow, thank you for watching. Thank you so much for subscribing. Thank you so much for commenting. Thank you so much for liking. I'm asking a lot. Yes, I am. But it's kind of boring over here without that interaction. I need some. So put it back there because you love me. Put some comment down below. Put a heart in there for me. Anyhow, talk to you later. Here comes the jingle. Bye-bye now.